Welcome back. Let's go to the next problem. Limits and graphs. Excuse me, there's a typo. Limits and graphs. Okay. And we have a graph of a function. It's a piecewise defined function. As you can see, we have some vertical asymptote forming here and horizontal asymptote forming there. Otherwise, no more asymptotes. Okay. Determine the given limit. And we have, well, all these problems. It's kind of difficult to see the graph and problem in the same viewing window. So let me move my graphs around. And I don't need font that big. Okay, all right. Okay, let's do it. What is the limit? X is going to -1 from minus side f of x. So x is going to -1 right here. And then from the minus side, so a little bit less than -1 and approaching this way. Approaching a little bit to the left. So if I follow the graph, I'm following the graph all the way down to the pit. Do you see it? From the left. So y coordinate is going down, 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 all the way down to -infinity. So the answer is -infinity. Okay, next. Now, -1 plus. X equals -1 is here, but plus, so a little bit bigger, so a little bit to the right-hand side. And I have to follow the graph, so let's follow the graph. X is going to -1 right here. And what happens to the y coordinate? Y coordinate is going to 2. You see, 1, 2 steps up. So the answer is 2. Previously, -infinity going down, and here, stopping at y equals to 2. Now, how about 1 minus? So +1, x is +1 right here, and 1 minus, so I'm approaching from the left, a little bit less than 1, so this way. Following the graph, go down, 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 all the way close to x equal to -1 right here. What's the y coordinate? Y coordinate is going to -1. -1. Now, how about limit for 1 plus? X equals to 1, but a little bit to the right, plus side. Let's follow the graph. Follow the graph going to x equals to 1 here. Now, what's the y coordinate? Y coordinate is going to 3. 3 steps up. So that's the answer. Next, let's go to -infinity. X is going to -infinity. So, but this way, all the way to the left-hand side, all the way to the other side of the globe. Follow this and then all the way, and you can clearly see this is horizontal asymptote. Getting closer and closer to the y equals to what? Y equals to 2. Now, how about +infinity to the right? Do we have an asymptotic behavior here following this? Looks like it's going up forever. So it's +infinity. So, all right. Given graph, you can find out these kind of limits, left-hand side or right-hand side limits, or left infinity or right infinity. You can do all these simply by tracking the graph. Just read the y coordinate value. Next set of problems are related to slopes. Okay. H is going to 0, and then this is difference quotient or Newton quotient. So this is a slope. Slope at x equals to what is the question? And then we have 2 plus h. So when x equals to 2, we have to read the slope. X equals to 2, the graph right here. What's the slope? It's a line segment, so it's easy to read. The slope is what? What's the slope of this line segment? Do you see this is -2? Rise over run, so it's -2. All right, how about x equals to 1? We have a problem. We have here or there, we have separation. So we do not have traditional slope, but we can still consider left-hand side slope or right-hand side slope. This says 0 plus, so right-hand side slope. Only to the right, completely disregarding what's happening to the left-hand side. From this dot to the right-hand side, what's this slope? It's the same line segment, so it should be -2 again. All right? Now, a couple more questions here. 3 plus h, 3, so x equal to 3. So we are looking at this point here, x equal to 3 right here. And then h is going to 0 minus, that's left-hand side, 0 plus, that's going to be right-hand side, all right? We have 0 minus, so left-hand side slope, 0 plus, right-hand side slope. So right here, from this point, where my mouse is, left-hand side slope, slope of this line segment again. What is it? It's -2. Okay, finally, the last question, at x equal to 3, right here, right-hand side slope, oh, that's a little bit difficult to estimate because this is curved, but if you look at carefully here, to the right, with horizontal tangent here, do you see? This is kind of parabolic here. Completely disregard what's happening on the left-hand side because this is h plus. To the right-hand side, in plus side, look at this horizontal line to the right, tangential. So the slope of horizontal line is 0. So the right-hand side slope is 0. As for A, B, and C, you can do precise observation because you're looking at the line segment. To the right-hand side, it's a reasonable guess, but anything reasonable I gave you, I intend to give you full credit, but as a matter of fact, to me, it's really clear this is horizontal tangent here. I mean, if this grid line had not been there, maybe it's not a bit difficult, but grid line is still here. So it's clear tangent is horizontal to the right. So slope is 0. A trick question. Let's go back to this problem here, problem B. Now, what if I give you this problem, which I'm going to name as B star or B prime, okay, and then go to 0 minus. What's this left-hand side derivative? Well, x equal to -1 here, and if you look at the left-hand side of this curve and then look at the slope, it looks like this is -3/2. It looks like rise over run, rise 1, 2, 3 steps down, so -3 as we move 2 steps to the right. Looks like that way. Is that the case? The answer is no. It may be a bit surprising, but this is no. Here to the right, we have right-hand side slope, which is the same as the slope of this line segment. To the left, no, it is not. That's because this point is hollowed out. Actually, the correct answer is undefined. To be a little bit more precise, this should be, let's see, positive infinity. Oh, I'll just say undefined. So you're not going to expect, let's see, I don't know, I don't want to pin down myself, so I may end up writing this kind of problem, but if I do, then of course this is a little bit higher level problem. So you see you have hollow dot here, so left-hand side, this part is discontinuous. You see you have discontinuity here. And so we don't have well-defined left-hand side slope concept here. To the right hand side, yes, because this point is solid. So when x equals to 1, this point is part of the right hand side. So yes, right hand side slope is well defined, and it is, as you saw, -2, this line segment, slope of this line segment. To the left, am I going to get this line segment? The answer is surprising, maybe. No, that's because this is hollowed out. Okay, so much for the graph problem. And let's stop recording here, and we'll discuss number 3, or the derivative problems, in separate videos.